Hi everyone, this is Sharan here. Welcome to my channel. The topic that we are going to see today is about date functionality in Pandas and about categorical data as well as sparse data. There isn't any relationship between these topics. It's just I have brought them all together for today's session. Coming to the first one, the date functionality. So this will be really important when you are working on and time series data, such as maintenance forecasting, let it be a weather forecasting or a spending forecasting for a particular user. So we need to have a time series data, and it is really important to understand about the various operations that can be performed on a time series data. In some cases, there could be some relationship from the day when we get our salary. There could be a pattern in the expenditure, like maybe 1 week from the salary date there would be an expense, X number of expenses, and so on. So in order to understand these relationships, it's often required for us to do some kind of a date operations and get all these patterns. So the first topic is about all the data operations. We won't be covering all of it, but we will be definitely going through some of the important ones, and I will be providing you some references where you can learn further. And the second one is about categorical data. So categorical data is really important. So categorical data means like it can pick up a value from a limited set of values, like gender, for example. Like it can take a value from a limited set. So there are some advantages of defining and variable as a categorical data. So we are going to see about how to define and variable as a categorical data, and what kind of operations or analysis that can be performed on a categorical data will be covered today. And the last one is sparse data. So this is really important, in order for us to save the memory. Like for example, in a particular data set, when there is an extremely large number of zeros or null values or like maybe an empty string, so in those cases it would make lots of sense for us to not use the memory to store all those zero values or null values. So if when we use sparse data, what happens is we would be storing only the values which are non-zero or not null, whereas the rest will not be stored, and hence a huge amount of memory will be saved. So this will be especially useful when we are working on an extremely large data set which has lots of missing values or data quality issues. So these three are the topics that we are going to see today. Let's get into the tutorial and then have a look into them one by one. So before going into the tutorial, the fact for today is about climates. So we all know there are various climates that we go through. Do you know the reason for it? So the reason for it is Earth is tilted at an angle of 23.4 degrees. If you draw an imaginary line from a north pole to a south pole. So at different time of the year, depending upon which part of the orbit that Earth is on. So the different parts of the Earth would be some parts would be closer to sun, some parts will be away from sun, and hence you see we have 4 different climates. And usually if you see the climates in the northern hemisphere as well as southern hemisphere will be exactly opposite. So when it is the winter in the northern hemisphere, if you move on to the extreme south, it would be a summer. So that's the reason for us having 4 climates in the year. And if you see the countries in the equator, there won't be much of a difference. So having said that, let's get into the tutorial. The first step, as usual, is importing the Pandas library, because all the functionalities that we are going to see today are part of Pandas library. So let's import Pandas library. So if this is the first video that you are checking out, I have mentioned a few times in the past in various videos. If you get any error while importing Pandas library, it is because that it is not installed properly. So you need to close this window, go back to the command anaconda.command prompt, and do a pip install pandas. Ensure that the Pandas library is all rightly installed, and after that, if you start Jupyter Notebook, it should all be all right. It should be working fine. So the first step is we are going to see how to create an time series data. So what we are going to do is we are going to use Pandas. We are going to use the date range, and we are going to specify the start date as well as the number of periods that we want to have. So let me execute and show this to you. So if you see here, like what happens is it starts from the date that we have defined and it increments by 1, and we get in total like 5 elements. So if I increase this to the number of periods equal to 10, so then what happens is we would get a time series data with 10 elements in it. The value starting with whatever we have defined here, and it increments by default by 1 day, and that's how it's being created. So let me just show you, like let me give a random date and then see what happens. So if you see here, so this is how it's been generated. So it's 1st of May 2011, 2nd May, and so on. That's how it works. So this is how we need to create and date series, which can be used in an data frame. So the second one is, let's say we want to add an frequency. So we don't want like every single day. Maybe we want just 1 day in a month. So we can add an frequency here. So here by frequency equal to m means that we are mentioning that the frequency should be monthly. So let me show what happens here. So as you see here, as I execute it, so even though the start date is 1st of Jan 2011, the first value is 31st of Jan 2011. So what happens is by default, when you use the frequency as month, it picks up the last date of that particular month. So as you see here, right, it picks up the last date, 31st of Jan 2011, like 28th of Feb 2011, and so on. There are various other options. Like for example, if we want to pick up the first date of a particular month, so if I execute this here with a month starting, so it would be picking up the first date in a particular month, and so on. So since the periods is 5 and the frequency is month ms, which is like the start of the month, so it picks up the first value of that month for 5 consecutive months, and that's how the time series data is being generated. If you want to know, like there are various other options, like various other frequencies that you can create. So if you are interested to know about all of it in detail, I would suggest that you go to this particular link here, so which is an tutorial in about the Pandas library, like especially for the date. So these are all the various frequencies that are available. Like you can use any of those frequencies. Like if you are interested in calendar date or weekly frequency, like semi-month, whatever it may be, there are like various options that you can choose. That's one of the advantages of working on Pandas. Like you have almost anything that you want or you are thinking about, there should be a functionality available to implement it. So you need not write too many lines of code. It's all built in. Like it should be available somewhere. You just need to know when and like where to use them from. So that's about creating an date series. So now let's see about the time delta. So usually when we are working on time series data, it's often like we work on doing some kind of an operations on a time series data, like be it finding the difference between 2 dates, or maybe finding like using a LAD function to understand, like to subtract certain number of days from a particular date and then see what's happening, like whether there is any pattern, and so on. So for these, you need to understand about the time delta functions. So this is what I'm going to cover here. So what I'm doing here is I'm just taking today's date and then storing it in a variable called day 1, and I'm adding 1 day to it and then storing it into the variable called day 2, and then just want to show what's happening. So when I execute this, so as you see here, so this is the date today, like when I'm recording this, the 3rd of October and 4:30 in the evening. So that's what is stored in day 1. So in day 2, as you see, like we are adding 1 day to it, and hence it moves on to 4th of October. And what we are doing is, in addition to the date, I'm using day2.dayname in order to get the day of that particular date. So which is tomorrow is a Sunday. So So these are all the various options that you have. So whenever you are working on a time series data, it's always good to get the day, because generally in a time series data there is lots of patterns depending upon the day. So for example, if you take your expenses, so there would be a pattern like expenses differ between a weekday as well as weekend. If you take your energy consumption pattern, there will be a pattern on a weekday as well as a weekend. So it's always good to make use of all these functionalities and see if there are any patterns, and if there are any interesting patterns, if you use those variables in your model, that will help in improving the accuracy. So the other date operations are some of them here. So here let me execute and then show what's happening here. So here what we are doing is we are creating an data frame with date as well as a column where how many days we need to add by default to the dates that's mentioned here. So here the first one is we need to add 0 days to it. Here we need to add 1 day, 2 day, and so on. And what we are doing here is I'm creating an additional column called as final date, and what I'm doing is I'm adding the date that we have here and the number of days which is present here. I'm adding both of them and then creating a third column called as final date. So as you see here, what's happening here is, since it is 0 days here, this is unchanged. 1st of Jan 2020, it remains same. So here we are adding 1 day to it. So from 2nd of Jan, it becomes 3rd of Jan, and so on. So let's see if I'm going to subtract the date. I'm going to use the same data frame, but what I'm doing is instead of adding the days, I'm going to subtract the days. Let's see what happens here. So when I execute it, it all becomes 1st of Jan 2020, because as you see here, so here the days to be added is incremented by 1. So the first one is 0 days, and after that 1, 2, and 3, so on. So when I subtract this column from the date, we always get 1st of Jan 2020. So these are all some of the operations that could be useful for you, like especially if you want to understand some kind of a pattern. For example, like as I said in the introduction, that could be some patterns in a day. Like for example, if an event happens today, like for example, if a salary is getting credited, there might not be an immediate behavior output for it. So that would be some lag. So maybe once you get an income, like that would be a lag of few days, and then you go and make a particular expense. So in order to find if there is any such pattern in the data as such, we can use all these lag functions to see how the correlation is when we use certain amount of lag or like any of these. So next one is we are going to use this query to extract the year, month, as well as date from a particular date column. So as you see here, when I'm using this, so where we are using the data frame, and I'm using the date column, and .dt, which is date time .year, would extract the year from the date column, and when we use dt.month, it extracts the month, and so on. So this can also be very useful in order to extract the year, month, and day, and to see if there is any patterns. For example, if we retain the date column as such, we might not be able to do the correlation on days. For example, let's say if there is a pattern in a month, so the expense during December maybe tend to go higher, whereas the expense in Feb tend to be very low. So if we want to do such kind of a correlation, we can't use directly dates, but we have to use the month attribute. So we can use these functionality to just extract the month or year or the day and see if there is any patterns in the data. So that's the usage of all these functionalities. So these functionality will be really useful when you are working on an actual time series data set. Yeah. So if you are interested in more time series operations, you can check out the link here. So this will be the link to the time delta operation. So this would have various operations that can be performed on a time series attribute. So it would be advisable for you to go through them and then try to have an understanding about what is possible and what is not possible, so that when we get started to work on the actual data set, it will be really helpful. So that's it about the categorical, that's it about the time series or date time attributes. So moving on to the categorical data. So as I said, categorical data is a variable. A variable, if it is defined as categorical, it means that it can pick up an value from a limited set of values. So usually, let's say we want to, the gender is always categorical, as well as, let's say we are going to group the population based on the age group. So maybe like a 0 to 20, 20 to 40, and various other categories. So then those can also be categorical data. In some cases, it's always better to use categorical data, provided there are some kind of there could be some kind of insights. Like for example, like the spending pattern of people between 20 and 30, if we find them all similar, instead of having that attribute age separately, it would make lots of sense for us to group all of them together, like group all of them whose age is between 20 and 30, and so on. So this helps in improving the accuracy of the model. Also, like depending upon the number of categorical data that we have, like certain models could outperform the other models. For example, when we have a data set with a larger number of categorical data, so the decision tree as well as random forest, it would perform slightly better than other models because they are optimized for categorical data. So let's see about what is categorical data. So we are going to define a series. So this is what the values that I'm going to pass on. What I'm going to do is I'm going to say the type is category. So let's see what happens here. So as you see here, the data type is category, and towards the end we can see categories and all the unit categories. So here there are only two unit categories, which is male as well as female, and both of them are coming up here. So in order to get all the categories, like I'm still using the same data set, the gender, so which is a series, Pandas series with all these values. So to get all the categories, just the categories, when I execute it, so as you see here, it's pretty much same. So but we are not printing it as a data frame, whereas we are printing that as an array, and then we are getting the categories. So now if we want to access the elements of the categories, so then this would be the first element. Always the index starts with 0, so it will be 0 and this would be 1. So here categories 0 would be the first one, which is female, and this would be male. So when I print this, you would be getting categories is male as well as female. So as you see here, so they are not ordered here. So it's not always same as what we see here. So 0 is coming up as male and 1 is coming up as female. And categorical data also supports some kind of summary function. So summary is something that we have already seen. So we can do some kind of a high level analysis about this particular categorical attributes. So here when I use this gender.describe, we would get a high level of summary analysis about this particular attribute. So let me execute and show you. So as you see here, we can get the count of the values, like number of elements that is present in this particular column, and how many unit values. There are only 2 unit values. The top one is female, like based on sorting, and the frequency of the top one is 3. So which means that in our data set there are 3 females and 2 males. So these are some of the high level summary analysis that can be performed on a categorical data. So now let's say we want to remove a category from a data. So what we can do is we can use remove underscore categories as function. So this is the data frame, and we want to do an operation on the categories. So we mention it as .cat and .remove categories, and what is the category that needs to be removed here. So that's mentioned here inside. So when I execute it, what happens now, if you see here, all the male values are deleted. So we can see not a number for it, and there are only 1 unit element, which is female. No other elements, it's all deleted and there is no value. That's why it's coming up as NaN. Yeah, so moving on to the next one. Next one is the sparse data. So as explained in the introduction, sparse data is especially useful when there is a large number of values in a data frame which is equal to 0 or null. it doesn't make sense for us to store all of them in the memory and then reuse them while building the model or doing the analysis, because it would be consuming so much of memory, which is very, very critical when we are working on a large number of data sets. So when we use sparse data on those attributes which has large number of zero or null values, what happens is only the non-zero or non-null values will be stored, whereas there would be all the null values or zero values will be pointed to some kind of a pointer, and there isn't any memory space wasted on them. So when I execute this one, so what is happening is I'm creating a data frame with a random values like 10,000 values, and what I'm doing is I'm defining like almost 9,998 of them as not a number, and the data type is being defined as float. So now when I execute this one, and so when I execute the data types, so as you see here, the data type is mentioned as sparse. So even though the value is float, so it's called as a sparse float, and then it says that it's not a number. So when I use the density function, so this tells me that how much of the memory is being used. So the memory is being used only for 0.0002% of values. So if I multiply this with the total number of attributes that we have here, so which means that out of 10,000 values, roughly about like not roughly, like it's the memory is being used only to store 2 values, whereas the other values are not being stored. So a large number of memory space has been saved. So this is something that will be very useful especially when you are going to work on a huge number of data set and that has a lot of data quality issues. So that's it for today. So today what we have seen is we have seen about a date as well as some of the functionalities that can be performed on a date attribute or time series data. And we also have covered about categorical data, like what is a categorical data, how to define them, and how to do a quick summary analysis on the categorical attribute. And the last one is about sparse data, like why it is being useful and how to define a data frame as sparse. So as you see here, we can use pandas.sparse data type to convert the data frame or a column in a data frame into an sparse data. And that's it for today. And there is a small exercise, like there isn't any question for you to solve today. So what you need to do is you can go into the Pandas documentation and then try to learn more about the time series data, what kind of operations that can be performed on a time series data. And for categorical data as well as sparse data, I would suggest that you maybe work on an actual data set, maybe get a title data set, and then identify all the categorical data, convert them into categorical data, see how it is coming up, how you are able to visualize them. And that's it for today. So I hope you have learned something new today. And if you liked this video and if you have learned something new today, give a thumbs up and subscribe to my channel to get notification of any new uploads, and try to stick on with me in this journey of learning data science in 100 days. If you think this might be useful to someone or your friend who is interested in learning data science, please share this with them. It always great to maybe work on a team or learn as a team or in a group, because your learning will be extremely fast. Yep. Bye for now. See you on the next session.